Everyone, welcome to the lecture series of data structures. I'm Amrit Kaur and I will be covering the topic selection sort algorithm. Let us see through the contents. First, I will be talking about the basic introduction on sorting. Then I will be discussing in detail about the selection sort algorithm and a sort example on how to apply this. Coming to the selection sort algorithm, let us first discuss what sorting is. It is basically a process of arranging a set of items systematically. For this purpose, we require some sorting algorithms that will rearrange a given array or a list of elements according to some comparison operator. Now, the comparison operator simply dictates the new order of the elements in the respective data structure. Talking about selection sort algorithm, it is a very simple algorithm which sorts a given array by repeatedly finding the minimum element in the array or an unsorted list, and then it puts it simply at the beginning of the list. So for this purpose, it considers that a given list is divided into two parts. First is an unsorted part, or we can say the right end of the list, and the second is the sorted part or the left end of the list. Initially, we simply consider that the sorted list is completely empty and the unsorted list is composed of the entire elements present in a given input list. So let us see through the algorithm of this sorting technique. So what we have over here is, first we have a for loop present over here that simply says that it picks up a minimum element in a given list or an unordered list, and for the remaining elements it keeps on simply checking for the condition, that is, if the element that is present in the list is less than the current element or the less than the current minimum element, then we will simply update the value of the minimum to the element that was currently picked in the list. And once this process keeps on iterating so that we traverse the entire list and a minimum is selected, after which we perform a swap operation, which basically does is it simply swaps the element that is a minimum element and brings it to the front end or the beginning of our list. So let us see this with the help of an example. Now here we have in step 1 is our list or our input list or an input array that is composed of integers. For this, first we see is simply pick up our minimum element in the list, which amounts to be the first element in the list present on the side of the unsorted array. And as you can see, I told you the sorted array is initially considered to be empty. So this particular region is empty. There are no elements present over here. This is just a bifurcation or a counter shift to determine that there is a difference between the elements present on the sorted side and unsorted side. So what we are doing over here is, now minimum elements amounts to be 64. As per the condition of the if operator, we will traverse and we will continue to check it with the remaining elements in the list one by one. 64 is compared with 25, and then we see over here that the current element, which is 25, is less than our minimum element that was chosen in the beginning, that is 64. So what we do is we perform our updation operation in which we update the value of minimum from 64 to 25. Now a new minimum is 25. Now this 25 is compared with the other element present in the list or the element that lies next to this particular element in the list or our array over here. The element present over here is 12. Now we check for the same condition, that our minimum element, that is 25, if it is less than the current element, that is 12, then it is fine. Otherwise the updation operator will be performed again. So here we see that 12 or the current element is less than our chosen minimum. So the updation operator simply updates the value of the minimum and assigns 12 to be the new minimum. So here we can see in step number 4 that 12 becomes a newly chosen minimum, and then we proceed with the same step, that is, we simply traverse the list of elements. Now this particular minimum is compared with the remaining elements in the list. So 12 is compared with 22, that is the next element that was present in the list, and it simply sees that now this minimum value 12 is less than the current element, that is 22. So no change is performed. It moves to the next element present in the list, that is 11. So as you can see in step number 6, 12 is compared with 11. Now we find out that the current element which is 11 over here, is less than our chosen minimum element, that is 12 over here. So our minimum gets updated with the value of the current element, that is minimum element becomes now 11. And since we have reached the end of the list, what we will do is we will simply perform the swapping operation. So swapping operation does what is, it will swap the value of the minimum, that is 11, which was present at this particular position, with the element present at the beginning of the list. So 64 is now swapped with 11. And now what we do is finally we increase the value of our counter shift. That is, we increment the value of a counter shift by one position, which is equivalent to the number of elements which are being shifted. So what we can see in the step number 9 is our sorted value is incremented, or we can say the sorted array is filled by one element in the list, and our unsorted element is thereby thus decreased by the same amount. So again we repeat the iteration. Now here we can see that the new element picked, or the minimum element picked, is again the first element in the list on the unsorted side, which is 25. We start comparing this particular element with the element present next to it, that is, it is compared with 12. Again we check for the same condition, that is, if our minimum which we have chosen or assigned in the beginning, that is 25, is less than the current element in the list, that is 12, then no updation is performed. But we can see over here as our minimum is greater than 12, so the updation operation is performed, as you can see in step number 11. In this we can see our updation, that is minimum, turns out to be 12 for this point of time. So now again for this newly assigned minimum, we will perform the same task. We will traverse the remaining elements in the list. 12 is compared with 22. Again no change since minimum is less than 22. Then 12 is compared with 64. Again we find there is no change since the minimum is 12 itself. So now we will do is the swapping operation. So in case of swapping operation, we simply swap 12 with the first element present in the list, and first element present in the unsorted list is 25. So we are exchanging the two elements with respect to their original positions. Now 12 comes to be at the beginning of the list and 25 moves at the position where 12 was initially present. So after this, finally we increase the counter shift value, that is the third step. In this, the sorted array is incremented by 1 again, and the unsorted array is thereby reduced. So again we begin our operation. We start with assignment of minimum to be as the first element in the unsorted list, that is 25. Now this 25, once it is assigned to be as the new minimum, is compared with the next element present in the list, that is 22. We check for the same condition if our minimum, that is 25, is less than the element that is currently picked up, which is 22. Then in case no updation would be performed, but in this case we can see that 22 is less than our minimum chosen. So what happens is we simply assign 22 to be as a new minimum. That is 22 becomes the new minimum, and we keep on traversing till we reach the end of the list or the end of the array over here. So we see once we have selected 22 to be the minimum, we compare 22 with 64, that is the next element present in the list. We check for the same condition. 22, that is our minimum, is less than the current element in the list, so no updation of the minimum is performed. And finally we do is the swapping operation. So in case of swapping, we simply swap the value that is present at the first position or the beginning of the unsorted list, that is 22, is swapped with the element that is 25, because 25 moves to the position of 22 and 22 moves to the position of element 25. Final step is we increment the counter shift by one position, that is the sorted array again has one element inserted at its sorted position, and the unsorted array thereby is forming short of one element at that point of time. So here we can see we have increased the counter shift. So these are the elements present on the sorted side, and this is the element present on the unsorted side. We again perform the same task and select 25, that is the first element present in the list, to be as the minimum element. This element is now compared to the next element present in the list, that is 64. So as you can see in the step number 22, our minimum element found is 25. It is compared with 64, and on comparison we find out that 25 remains as the new minimum itself because 65 is greater than that. So no change is taking place. So we simply move towards the second step, that is swapping. Now in case of swapping also, we realize we need not to perform swap operation because 25 is already present at the beginning of the list. So what we do is we simply perform the counter shift operation. So in case of counter shift operation, we can simply say that this particular counter moves from this position towards this side, that is towards the right side. So as you can see in the step number 24, the counter shift position, that is the final operation. This operation is performed and it moves by one position. Sorted array is incremented by one position and unsorted array is thereby decremented by one position. So finally we do the same iteration. Now since 64 is the only element left, this turns out to be the minimum element in the array, and no more comparisons or swaps are required because there is no other element left. We will simply increase our counter shift by 1 And what we can see over here is the final completed selection sort algorithm giving us a sorted array over here, which increases by the same number of elements that were present, and the unsorted array thereby becomes entirely empty. So the complexity amounts to be big O of n square because there are two for loops that are involved over here. So I hope the example is clear. Here are the few references. Thank you so much.